Find a reduction formula for in, which is the integral. So here's the n. The n is always a good thing to keep track of, because for a reduction formula, I'll read the rest of it in a moment. For the reduction formula, we want to rewrite in terms of sort of smaller values. Same integral, but smaller values is what we're shooting for. So the n is sort of always on our mind. But it's 1 over 5 minus x squared to the n. Okay? That's the one we're after. So I'm going to go over to my notepad here. I'm going to copy it down. 5 minus x squared to the n. All right, so this is what I've got to work with. Now, a great strategy, it's not the only strategy, but a great strategy might be to use something like integration by parts. And your first thought might be, okay, well, with an n there, unless n is 1, I could always split off a copy and split this into 2 bits. And that's a great strategy if you're trying to make integration by parts apply. Split up a power into sort of 1 copy, and then you notice, hey, look, I've got my n minus 1. The problem with this is, if I'm going to try to do integration by parts, I need a u and I need a dv, which means both of these, or one of these needs to be able to be recognized as a derivative. I definitely don't know what you would differentiate to get this as a derivative. So it would have to be this, but with that minus x squared in there, I really don't know what the antiderivatives of this are off the top of my head either. I mean, I could try and do something, to rewrite it or rearrange it, but off the top of my head, nothing is immediately springing to mind. And typically when you do integration by parts, you want to be able to say, aha, this should be my u, aha, this should be my dv, without too much fuss. So while splitting up like this might be a valid strategy, I can't really see how to make it work. Now, when we run into roadblocks, we don't just give up. We don't just say, well, okay, better luck next time. I'll go find some other question that I like doing. No, let's actually handle it. But maybe we need to try something else. Maybe integration by parts isn't what we need. Or maybe it is, but we'll need it later on. Maybe we've got to do something else first. Now, the big problem with integrating that 1 over 5 minus x squared is, well, the derivative of 5 minus x squared is sort of roughly, it's 2x. I mean, it's minus 2x. And I don't have one of those lying around to help us out. But could we find other ways of turning this n into an n minus 1? Yeah, actually, we could try and use a strategy for rewriting, not just jumping straight into the integration. Here's what I'm going to do. I'm going to divide top and bottom by 5. Okay? You'll see why I'm doing this in just a moment, but I want to get a 5 up here, because this 5 here can also be just 5 plus 0. We can always add 0. You can always have a sneaky little 0 here. And what I'm going to do with that sneaky little 0 is I'm going to write it as minus x squared plus x squared. All right, you see how this might start to be coming together? Because now I can split up this fraction. And we're going to have this 1 over 5 out here for a while. Okay, but I'm going to split it up. I'm going to take the first 2 over my 5 minus x squared to the n. And think for a moment as I write the next part out, how's that going to simplify in a second? And then plus, get this x squared over 5 minus x squared to the n here. Well, we've got 1 copy of this on top, so we can cancel out with 1 copy of it on the bottom. Look at that. This is I with degree 1 less. Now, it's important to understand, when I started doing this question, because they did not give me an example reduction formula, they did not say, hey, prove this reduction formula, I didn't know that we were going to n minus 1. It's entirely possible, especially with that square there, that maybe we'd get everything in terms of n minus 2 or something like that. But yeah, I managed to reduce it down to a smaller n. So I'm going to multiply this 1/5 here and say, look, we've already got something smaller. Great. But we do still have all this other leftover stuff here. Okay? So what can we do with that? Right? It's not a reduction formula if you still have other integrals to do. The point of a reduction formula is to rapid fire quickly do a bunch of integration, and we don't want to have to integrate this guy with its n every single time. So can we simplify this? Now, when I look at it, remember that comment I made a moment ago about, oh, I wish I had the derivative of this here, because then we could do a substitution. Well, we have an x. In fact, we've got 2 x's here. So I'll get out my blue here. I'm going to just focus on this part here. Don't worry, at the end we'll bring it all back and we'll get our final answer. But in fact, I'm not even going to focus on the 1/5. I'm just going to focus on this integral here. Okay? So we're just going to focus on this. How can I deal with this? And it's perfectly valid to say I don't want to drag around everything else. Let's just focus on this one little part of something. Now you might say, well, how about we subtract a 5 and add a 5? That's going to be going around in circles. Okay? So here's what I'm going to do. I'm going to get out an x. I'm actually going to separate this x squared as to 2x as x times x. Okay? And I'm going to do a very similar strategy to what we did with that 5. I'm going to multiply top and bottom by -2. Because then this -2 here is the derivative of this guy here. Right? The 5 minus x squared. So now, if we take a look, I'm going to highlight, we've got a little x running around, but then we have this function, which I'm pretty confident I can integrate. So now I've got two things multiplied together. Now I think we can do integration by parts. Okay? So to make it very clear what I'm going to try and do, I'm going to let u be x, and I'm going to let dv be this big monstrosity here. Okay? You might say, you're crazy. What are you doing? Save yourself. No. Because I think I can do a quick substitution. It's going to, well, quick is in the eye of the beholder, isn't it? So my du would be dx. But now let's find a v. So v has to be an antiderivative of this. I've already used u, so I'm going to say something like, let's let w be 5 minus x squared. So then dx is going to be dw over minus 2x. So we get minus 2x, w to the n, and then dw over minus 2x. Goodbye minus 2x's. Now I've got 1 over w to the n, or w to the negative n. And look at that. It's power rule, right? We're doing it. So we'll get w to the minus n plus 1 over minus n plus 1. Or another way to say that, well, I'll write it in just a moment. But another way to write this would be 1 over w to the n minus 1, and then n minus 1 like this, and the minus sign there. But we don't need the plus c because we just need an antiderivative. So I'm going to switch back to black because I find it's a little easier to read. But we've got this minus 1/2 here. Integration by parts says, okay, you take your u, you take your v, which is, well, we'll have to put the w back in, but we'll get x times -1 over n minus 1 times my w, which was 5 minus x squared, but now to the n minus 1. So that's my function minus duv. Well, the du is just dx. And then what have we got? A -1 over n minus 1. Those are constants. 5 minus x squared to the n minus 1. So the minus signs, we can start messing around with those. Those go away. And then we can bring out the 1 over n minus 1 here. And I'll write this a little bit clearer. We got minus 1/2 negative x over n minus 1. 5 minus x squared to the n minus 1 plus some constant times, and what is this? 1 over 5 minus x squared to the degree 1 less. This is my n minus 1, my I n minus 1. So we're done. We finished all the integrations. Everything is either an integral of the sort of smaller form I n minus 1, or it doesn't have any more integrals in it. So now all I have to do is take this little piece and stitch it back with everything we already knew. I n was, don't forget that 1/5. So 1/5 I n minus 1. Was it minus or was it plus? Plus 1/5 times this other stuff. So minus 1 over 2 times the minus x over n minus 1. We'll clean all this up in just a moment. Okay. So that, and then minus 1/2 times plus, so it'll be minus again, minus 1/2 n minus 1, and then it was I n minus 1, right? There we go. So, let's not forget that 1/5 as well. So it'll be actually over 1/10. So we're nearly done. We are nearly done this one. It was an integration by parts. Let's see, the minuses will cancel out. We'll have x over 10 n minus 1, this guy here. And then we'll get 10 here, so minus 1 over 10 n minus 1 I n minus 1. It was integration by parts, but it just took us a little while. The last thing to do is sort of combine these. So let's get a common denominator. So multiply top and bottom by 2. Multiply top and bottom by n minus 1. So that'll be 2n minus 2 on top. So 2n minus 2 over 10 n minus 1 I n minus 1 minus this guy here, which is minus 1 copy of the n minus 1, plus, I'm just going to copy this guy for a moment. So 2n minus 1 minus, n minus 2 minus another 1, we'll have 2n minus 3 on top. So here's my final answer. In is, let's see, what was it? X over 10 n minus 1, 5 minus x squared to the n minus 1, plus, now we've got 2n minus 3 on top, 10 n minus 1, and then the smaller version. There it is. At long last, it took us a couple interesting rewrites, introducing that 5, introducing that minus 2, and then eventually an integration by parts, but we got our reduction formula all safe and sound.